Okay, this video accompanies our 6-4 additional practice proving a quadrilateral as a parallelogram. So let's see what we got here. So let's see, you need to do all of these. So I'm just going to go through some selected problems. Like I'll do 1, 4, 5. Let's do 7 and 9, and then we'll set up number 10. So let's see what we got. Okay, so for number 1, they're showing us that we have a quadrilateral, and they're showing us that opposite sides are congruent. If opposite sides are congruent, then we have a parallelogram. So yes, this is enough information to show that it's a parallelogram. Now, talking about number 2, they're showing one side is 12, one side is 11. You have to ask yourself, is there enough information to know that this opposite side is a 12? Is there enough information to know that this opposite side is 11? I don't think there is. So number 2 would be an example of one that would not be a parallelogram. At least we couldn't say that it was a parallelogram with the given information. Looking at number 3, another property of parallelograms is that opposite angles are congruent. If it's a parallelogram, these same side interior angles are going to be supplementary, and we can see that 78 and 102 do add up to 180. So this top and bottom side is parallel. Opposite angles are congruent in a parallelogram. Supplementary to 78 going the other way would be 102, and now we have opposite angles congruent. So yes, it is a parallelogram. Number 4, they're showing us with the way the quadrilateral is marked that opposite angles are congruent, so it must be a parallelogram. Let's look at number 5. For these, we want to find values that will make these parallelograms. So number 5 deals with side lengths. What they've done, though, is they've messed around with this a little bit because they're mixing the A's and the B's up. So let's see what we can do. This is almost like an Algebra 2 thing, but there's a way we can kind of get around it. Let's see. If we look at the top and the bottom, we have B is equal to 3A plus 1. So what we can do in one of these, this other one where we have 5A must be equal to 2B minus 5, we can substitute for the B that it's equal to 3A plus 1. So let's see how that works. So I'm going to take 5A is equal to 2B minus 5, because if it's a parallelogram, those opposite sides need to be congruent. But now, from the other set, we have that B is the same thing as 3A plus 1. So I'm going to replace the B. I'm going to substitute for the B with 3A plus 1. Let's see what we get. We got 5A equals 2 times the quantity 3A plus 1 minus 5. So distributive property, 6A plus 2, take away 5 on that side, 5A on this side. Take 6A away from both sides, got minus A on this side, and 2 take away 5 is a minus 3. So we have minus A is a minus 3, multiplied by negative 1, A is equal to 3. So if A is equal to 3, this side's going to be a 15. This is going to be 2B take away 5. B is 3A plus 1, so B is going to be 3 times 3 plus 1, which is 10. And 20 take away 10 is 15, so we got opposite sides equal there. And then 3A plus 1, 3 times 3 plus 1 gives us 10, and B is 10. So we can demonstrate that opposite sides are congruent. So we've got a parallelogram for number 5. For number 6, you're dealing with the angles. So the way to start with number 6 is those two angles are a linear pair because those are consecutive angles, and consecutive angles in a parallelogram are supplementary. So you're going to do 12B plus 8 plus 5B plus 2 is equal to 180. Find the B, and you have those angles, and then you can figure out that whatever this angle here is, when you put the B in, has to be equal to 2A since it's an opposite angle, and you can make it a parallelogram that way. Okay, let's look at number 7. Number 7 is dealing with the diagonals. We have a parallelogram, and in a parallelogram, the diagonals bisect each other. They're not showing anything about right angles being there, so we can't say that it's a rhombus or anything like that. but the diagonals bisect each other. So let's see. They're telling us that this diagonal here is 5a minus 4, and this other half of the diagonal is 2a plus 14. Since the minor diagonal bisects the major diagonal, we can set 2a plus 14 equal to 5a minus 4. Okay, grouping like terms, take away 5a, we got minus 3a on the left. Take away 14, we have minus 18 on the right. Minus 3a's is minus 18, a is going to be 6. Now if a is 6, 12 and 24 makes 26, and this top piece is going to be 26. So we found out that a was 6, and for the minor diagonal, a is half the minor diagonal, which is 6. So 2b is the other half of that minor diagonal, which also has to be equal to 6. So if 2b's is equal to 6, b must be 3. And so for b equal to 3 and for a equal to 6, we have a parallelogram because we can show that the diagonals bisect each other. Number 8 is looking at opposite sides being, you got a set of parallel sides here. So if you can get one set of opposite sides both parallel and congruent, you got a parallelogram. But again, they mixed up the a's and the b's. So let's see what we can do. If it's a parallelogram, opposite sides are going to be congruent. So let's start with like 5a plus b must equal 2b plus 15. So take 5a's away from both, let's see, take 2b's away from both. Let's solve this for b. So we've got minus b is equal to minus 5a plus 15. Or b is going to be 5a minus 15. So we got our b. So double check, make sure it's right. 5a, we've got a single b with a minus, okay, so that's right for b. So now what we can do with this other set, since they have to be equal, we can substitute wherever there's a b with 5a minus 15 and get everything in terms of b. Let me change colors. So we, for these two sides to be congruent, we would have 4a plus b would equal 5b minus a. But b is the same as 5a minus 15, so I'm going to substitute that in. So we have 4a plus b, which is 5a minus 15, is equal to 5b. Okay, so 5 times b is going to be 25a minus 75, and then we have a minus a. Okay, so let's simplify that. 9a's take away 15. Oh, those aren't mine. Thank you. Is equal to 24a's minus 75. Okay, add 15 to both sides, we get a minus 60. Take 24a's away from both sides, we get a minus 13. Is that right? Minus 15. Minus 15. That's better. So we have minus 15a's is equal to minus 60, so a must be 4. So if a is equal to 4, down here where we did the thing for b is 5a minus 15. 5 times 4 is 20. 20 away, take away 15 is 5, so b is 5. So if a is 4 and if b is 5, we would have opposite sides congruent, and number 8 would be a parallelogram. So these are more advanced. These are more like Algebra 2 level problems. But if you can kind of see how that substitution worked there, that's something that you should be aware of. If you can see how to do it, you should try it. Let's look at number 9. Okay, so Margaret says there's not enough info to show that this is a parallelogram. Let's see what we got. We got opposite sides labeled as parallel. By definition, if opposite sides are parallel, and you have a quadrilateral, you have a parallelogram. So there actually is enough information to show that that's a parallelogram. Okay, let's look at number 10. We got this hazard sign. These stripes are parallelogram shaped. He's got 144 inches of tape. So this is really a perimeter problem. Let's see, we got 1, 2, 3, 4, 5, 6 sides of this stripe, of these stripes need to be covered with tape. So we got 6 of those, and we got to figure out how long each one is. This is, we use Pythagorean theorem on that. This is a right triangle. This is the hypotenuse is what we need to find. We've got 6 and 18, so 6 squared plus 18 squared is going to be equal to, let's just call it C. It's going to be equal to C squared, which is the length we need. We're going to have 6 of those C's, plus the width is 3 inches, so we got 1, 2, 3, 4, 5, 18 more inches. So ultimately, we want to see if 6 times C plus 18 for some C is less than or equal to 144 to see if he has enough tape. So 6 squared is 36. 18 squared, something 4. I can't remember 18 squared. Hold on. What's this? $18 squared is 324. So we add those together. 36 and 324 gives us 360. And that's going to be equal to C squared. So we want the square root of 360. Now, in simplest radical form, that's going to be 6 root 10. But decimal-wise, let's see what the square root of 360 is. So the square root of 360 is 18.97. So we'll just call it 19. And so to answer this, so it's about 19. And so is 6 times 19 plus 18 less than 144, because he only has 144 inches of tape. So 6 times 19 is going to be 114, and 18 gives us 132. So it looks like he's going to have about 12 inches of tape left over when he does the outline of these stripes. So yes, he does have enough to finish the job, and he would have about 12 inches left over.